Welcome to the Hudson Institute. I'm Bryan Clark, a senior fellow at the Institute and director of the Hudson Center for Defense Concepts and Technology. We are really honored today to have a terrific discussion about the future of warfare and some of the trends in military operations, particularly looking at concepts like decision-centric warfare and Mosaic Warfare. Some of these ideas have been initiated and implemented by DARPA over the last several years, and we want to talk about the trends there and also the trends more broadly in what's going on in military operations as the DoD wrestles with joint all-domain command and control and a joint warfighting concept for the future. To help us with this discussion today, we're pleased to have with us Dr. Dan Patt from the Hudson Institute, as well as Mr. David Spirk, who's the Chief Data Officer for the Department of Defense, and Dr. Tim Grayson, who's the Director of the Strategic Technology Office over at the DARPA, the Defense Advanced Research Projects Agency. Before we go to the panel, I want to give a quick brief to talk about what we mean by Mosaic Warfare and Decision-Centric Operations. That brief is drawn from work that we've done at Hudson over the last several years, looking at this trend in warfare away from small numbers of large monolithic platforms towards a more distributed force that is more recomposable and adaptable. The work we've done has been encapsulated in a couple of reports that we've issued over the last year. Last year, we published Implementing Decision-Centric Warfare, Elevating Command and Control to Gain Optionality Advantage. And then earlier this year, we published Advancing Decision-Centric Warfare, which is focused on mission integration. So these two studies kind of bookend some of the work we've done on Mosaic Warfare, focused on the first one on command and control and the second one on force design. And I'll talk a little bit about that during the course of this brief. The impetus for a shift in the way that military operations are going to occur is the emerging capability of China as a pure competitor. China is growing both the capability and the size of its military through its modernization program. It is unlikely that DoD is going to be able to really spend its way out of this challenge. We can't necessarily grow the military of the US fast enough and make it better fast enough to be able to address the China challenge in the time frame it's likely to manifest. As Admiral Phil Davidson said earlier this year, rather famously, within 6 years, we may find that China is able to try to take Taiwan by force. So the normal modernization process for DoD is unlikely to result in a dramatically better military by then. So the shift that we're looking to have is away from that traditional path of military modernization and looking to try to get a decision advantage by redesigning the force, if you will, and redesigning our command and control processes to create a force that's more adaptable, creates more complexity for enemies, and creates more flexibility and options for US commanders. By getting that decision-making advantage, we hope to be able to deter China and Russia and other aggressors from attacking US allies or even the US homeland itself. The rise of China, you could argue, is the culmination of what has been the most recent revolution in military affairs, which involved stealth and precision. So as you can see on this chart, you could argue that there's been several revolutions in military affairs since the beginning of the 20th century, first with World War II and the rise of mass industrial capacity and that the ability of industrialization to win a war. Then the nuclear weapon being introduced in the Cold War and the ability of nuclear weapons to give you a warfighting advantage that eventually reached parity between the United States and the Soviet Union. And then most recently, you see the rise of stealth and precision networking and precision weapons to enable a military to be able to be much more efficient in how it delivers fires and much more capable of penetrating enemy airspace. So these trends have now resulted in China and Russia both being able to deliver similar capabilities to the United States. And now we're at an inflection point where we need to think about, well, what is the next revolution in military affairs? That next revolution may hinge on new technologies that are becoming dominant, like artificial intelligence and autonomous or unmanned or uncrewed systems. As we saw with previous revolutions in military affairs on here, the dominant technology of the time ends up sort of driving the operational concepts that enable that revolution. So these two technologies are somewhat dominant today and arguably will help result in a force that's able to gain an advantage over the one that's focused on precision strike and networking, as we saw during the Cold War. To achieve this new force design that's able to leverage AI and autonomous systems, we need to think about disaggregating the United States military away from a small number of large monolithic multi-mission platforms towards a more adaptable force that's composed of a larger number of less multi-mission and maybe single function type systems, as you can see here on the diagrams or on the chart. You could take an F-22 rather than F-35 in this case, and transition it to be an F-35 plus a series of unmanned vehicles that now can adapt the way they operate in their composition in lots of different ways than what the original F-35 might be able to do. If you take this to a force-wide change in force design, you can see for the Navy what that might look like is a transition from what's on the left-hand side of this chart, the black force, which is a relatively small force of multi-mission platforms, and divests of some of those large multi-mission platforms to fund the development of smaller, less multi-mission platforms like unmanned surface vessels, unmanned undersea vessels, and then just smaller logistics and fires vessels. That larger force could give a commander in the field a lot more opportunities, a lot more different ways of composing the force, a greater adaptability, and then also impose more complexity on the enemy's decision-making, who will have to now try to diagnose what US forces are likely to do and how. In a lot of ways, this represents trends that are occurring in the commercial world as well. So if you look on the right-hand side, you could argue that this is similar to the trend of delivering solutions at the point they're needed rather than building solutions in a centralized location. So we've seen with the advent of, for example, mobile computing, you can now adapt your iPhone to whatever configuration you want for the specific services that you want, rather than how you might have looked at a second generation phone, which had a set of functions that were created by the manufacturer and could not be modified in the field. So this shift of solution development from a central location out to the edge is something that's happening commercially. We can also see how that might happen in the military as we shift to these more distributed force structures. The distributed force structure that we're talking about here will give commanders more options. It would be able to give them a potential decision-making advantage over an opponent has fewer options available to them, imposes complexity on the opponent. So this is an example of what we call decision-centric operations or decision-centric planning, where the focus of planning is on creating adaptability and optionality for the leader, rather than forecast-centric planning, which is designed to predict a ideal force configuration and then efficiently allocate resources towards that configuration. The forecast-centric approach works when you are a dominant military, like the US was for the several decades following the Cold War, where you could sort of drive the terms of engagement, the location and timing of a confrontation. And therefore, a predicted situation is likely one that you could create. So you could use a predictive sort of model to divide what kind of force you need to be successful. Now, against a pure competitor, we need to think about the fact that we don't drive the terms of engagement, and we need more options to be available to commanders. That decision-centric approach, as you can see on the bottom, tries to afford more options to that field commander, and in the planning process, more options to force developers, so that we can have a force that's able to create more complexity for opponents and hopefully provide a decision-making edge to the US commander. Harnessing or being able to manage this more disaggregated force, though, is going to be challenging. So we need to turn to a new way of doing command and control. Instead of our current kind of human-based planning processes with staffs that try to develop plans, we need to think about using machine-assisted control to a much greater degree to be able to formulate force compositions, force packages, and then build CONOPs that those forces could implement. This is not dissimilar from how, like, the Uber app works, where you ask for a car to arrive at a certain location at a certain, or you ask for a ride from one place to another, rather, and then the Uber app proposes a series of solutions to try to meet your needs. This would be a similar idea here, that these human command and machine-assisted control would allow human commanders to then be able to work with a machine-assisted control system to devise courses of action and implement those courses of action on a much faster time scale than is possible with a human staff. It would also open up the decision space, because this machine-assisted control system is likely to look at a lot more options than a human staff would ever be able to do. The machine-assisted control idea also enables us to do mission command, which is the approach that the military would use when communications are down between junior commanders in the field and senior commanders at headquarters. Those junior commanders are expected to initiate, take command, follow the commander's intent, even when they don't have communications, and try to continue the operation. The challenge with a more disaggregated force, as we give more kit to these field commanders, it gets harder and harder for them to be able to develop courses of action in the field without some kind of staff, which they don't have. So planning tools like we're talking about with machine-assisted control could enable that field commander to make better use of the capabilities they have available to them, and would also help them to understand what forces and capabilities are available, because they may not know immediately which units are in communication with that field commander. So this idea of mission command allows you to make your command and control structure adapt to your communications availability, rather than trying to build a communications architecture that's going to survive in any environment, which is probably a fool's errand because of the challenges that a country like China could pose in the electromagnetic spectrum in the vicinity of their own territory as the home team. So Mosaic Warfare and Decision-Centric Warfare, really by combining this command and control process with this force design, gives us two main avenues of benefit. One is institutionally, it lets you adapt the force more quickly and respond to changes that the opponent's trying to drive over the course of a competition. So one example of that, if you look at it, is how U.S. development of the F-22 parallel development of the air defense systems against which it was supposed to be operating. Russian air defense systems went through multiple generations during the time that the U.S. was developing the F-22. The F-22 is an exquisite aircraft and arguably the best fighter that's out there still, but it's still not going to be as adaptable as the air defense systems against which it's operating. Now, arguably, that's because the air defense system is simpler, has less functions, but that's exactly the argument we're making here, is that by shifting to a force that's composed of more of these less multifunctional systems, you create that adaptability to be able to try to deal with opposing efforts to gain advantage. The other avenue of advantage that Mosaic Warfare provides is on the operational level. So if you think of the OODA loop and how we observe, orient, decide, act to formulate a course of action and implement it, a more recomposable force composed of a small number of large multi-mission platforms and a large number of small, less multifunctional platforms has more adaptability. It gives you a greater number of options available, so the decision and act parts of your cycle are faster. It also makes it harder for the opposing side to see what you're doing. So their orient part of the cycle is degraded. So decision-centric warfare focuses on both sides of the competition, both improving our ability to make decisions and implement them, as well as degrading the opponent's ability to make decisions. We saw that play out in war games that we did to implement Mosaic Warfare, where because the Mosaic force had this greater number of options available, commanders were able to make choices more quickly. They could also scale the level of forces much more, calibrate them much more closely to the need, and therefore spread the force out over a larger number of tasks. And that meant together the tempo or the speed with which they could make decisions and the ability to spread the force out over more actions meant that the Mosaic force was able to simultaneously conduct more operations compared to the traditional force. And as a result, gained significant advantages over the enemy, which was unable to keep up with the number of options being presented to them and also the number of operations being conducted simultaneously. Now, institutionally implementing something like Mosaic Warfare is going to run into some roadblocks. One, we talk about the need for a new command and control process and a change to the force design. Those are both going to be difficult lifts, but those are arguably both happening. So the department is moving towards more distributed force structures, and JADC2 is moving towards new approaches to command and control. The remaining barrier is going to be, how do we integrate forces in the field? Because that's where the solution has to be generated. It can't be something we generate back here in the CONUS. And right now the situation is, if you look at this diagram, we devise a force design in the Pentagon, and then that force is built and then prepared for deployment by the services. And then once it leaves the services, it then is integrated in the field for joint operations on an ad hoc basis, essentially. So combatant commanders are faced with the prospect of having service-generated force packages coming out to them, and then having to repackage them or reorganize them to serve particular mission needs. So combatant commanders aren't really equipped very well to do that mission integration function. As you can see, there's a big gap there. Once you leave the service force generation process, there's nothing else that does joint integration after that. So we argue for the implementation of some kind of process by which combatant commanders can do mission integration in the field, and then be able to tap into the force development processes in the Pentagon or elsewhere in DoD to be able to help them do that when they need new software chains built or when they need new systems modified to enable that mission integration. The implementation of this approach also means we need to start thinking differently about how we do requirements and acquisition. We need to think about, if your force is more adaptable in the field, it may not have a particular instantiation. So my requirements need to be based, instead of being on a particular performance parameter like speed, lethality, range, it needs to be based more on adaptability. How well can this system integrate with other systems to form different force packages? And one way to think of that is, if you look at this diagram, evaluating force packages, evaluating new capabilities in the context of force packages and evaluating those force packages in the context of a wide range of scenarios. So something that is effective in a wide range of scenarios is going to be more valuable than something that's highly effective in a small number of scenarios. And that's what this new process would have to ascertain, because you're trying to focus on adaptability rather than sheer performance. And the last thing we think about institutionally is budgeting. Now, the budget process has not changed very much, despite we've had multiple cycles of acquisition reform. And if we want to be able to enable mission integration, we need to have a way for mission funding to be allocated. So mission managers and mission integration cells in the field will be able to put money against capabilities that don't belong to any one service, but are essential to be able to knit together a force package that enables a new operation or a mission to be conducted. So thinking about mission element funding rather than program element funding is going to be an important element of implementing Mosaic or decision-centric warfare. With that, we're going to turn it over to the panel, and I'd like to introduce them now. With us today are David Spirk, who is the Department of Defense's Chief Data Officer. He's responsible for strengthening data management across DoD and accelerating transition to a data-centric culture. He's overseeing key enablers such as data governance, data standards, policies, and implementation of DoD data strategy. He's previously served as U.S. Special Operations Command Chief Data Officer. He was the first of those, where he created a data-driven decision-making culture and implemented artificial intelligence, machine learning, and automation across SOCOM. He's also been the Associate Director of Technology Investment at the Secretary of the Air Force's Concept Development and Management Office for Advanced Analytics and Technology Investment. And he's also, as a former Marine, was the first Marine intelligence officer on the ground in Afghanistan following September 11th attacks. As a member of the 26th MU, participated in the seizure of Kandahar airfield and the reopening of the American embassy. And he's a longtime intelligence professional, having worked at the Director of National Intelligence, working at U.S. Central Command and at U.S. Special Operations Command. Dr. Tim Grayson is the director of DARPA's Strategic Technology Office. He leads development of breakthrough technologies to enable warfighters to field, operate, and adapt distributed, joint, and multi-domain combat capabilities, including communications, electronic warfare technology, supporting tools, decision aids. He came to DARPA from a career in government and industry. Most recently working at having founded Fortitude Mission Research, LLC, where he helped DARPA with the effort to develop the DoD modernization strategy, a blueprint for winning, which was developed during the last administration to help modernize the Department of Defense. He has previously worked at the Central Intelligence Agency, where he was a senior intelligence officer focused on science and technology, and was a program manager at DARPA. He has a doctorate from the University of Rochester in physics and a bachelor's from the University of Dayton with minors in mathematics and computer science. So we are pleased to have these three gentlemen with us today. Dr. Dan Patt, I will turn it over to you for what I hope will be a really interesting conversation.
Thanks, Brian. And I'm definitely looking forward to this conversation, and especially with you two, and on this set of topics, which I think is so timely and so important for the department right now. Tim, at least by DARPA standards of what long is, we've been on this Mosaic journey for a while. So what a great time for a retrospective. When I think back to the beginning of this, and thinking back to sitting around a conference table with you, I am encouraged to think about how my own thought has progressed. And one thing is, in the very beginning, thinking about Mosaic, cooking up Mosaic with you, I was really focused on attrition of defended targets, really how you could get more effective using distributed force structure. And as time's gone on, my own thinking has shifted, and I'm much more interested in shaping decision-making. My question to you is, when you think about Mosaic and you think about what you've learned, what you've done over the past several years, growing and maturing a portfolio, what are some of the things where your own thinking has progressed?
Yeah, great question. And first of all, Dan, Brian, thanks for the opportunity to be here today. And Dave, it's great to share the virtual stage with you. So I'm going to go into the real Wayback Machine. My first program as a program manager at DARPA, which was actually in the late 90s when people were first starting to say net-centric, was this program called AMSTI that was netting a couple of GMTI sensors together to do precision tracking. And everyone kept saying, what good is it to net things together? And, so it took over almost a decade and a half to really get serious. I mean, there have been some system of systems programs, but our colleague, Dr. Nils Sandell, when he was in this job, going back to the early teens, focused on system of systems. So we have this arc that says, yeah, it might be useful to actually net things together, to net everything together in the system of systems mindset. And then, we started working together and said, well, there's a problem with this just net everything together in a system of systems. And it pokes a little bit to some of the things Bryan was talking about. It's the brittleness. The likelihood of getting exactly the right network at exactly the right time, or building the Uber network that covers everything, the chance of able to do that is vanishingly small. And we'll probably talk more about that in this discussion. So, Mosaic originally was, as you said, increasing optionality. And that thinking hasn't disappeared. But as it's evolved, and one of the things I often talk about when we think about how we're going to transition this Mosaic concept is I talk about the 3 waves of Mosaic. If I want to be parochial, or I'll say the 3 waves of JADC2 or joint warfighting concept, if I want to be broader. Wave 1 is sort of that system of systems mindset. And it's also captured by a lot of the joint warfighting efforts going on around the department, things like Air Force ABMS, things like Project Convergence, and fielded systems like Navy's NIFCA. And so there's goodness there. We have to go somewhere. Back to the question that the DARPA director asked me in 1998, what good is it to net things together? We have to demonstrate that. That's wave 1. But we don't want to stop with being locked into brittle single kill chains, single integration webs. So our original thoughts of increased lethality, provide options, confuse the enemy, Bryan's chart that showed all the big capital ships being replaced with a bunch of little things, swarms, all of that. That's still sort of in the thinking, but we've pushed that back to wave 3. And the reason for that is twofold. From a technology standpoint, when we look at that kind of model, we run the risk of falling into this change everything and boil the ocean. And from a technology perspective, that's a dangerous thing because of the complexity and the way complexity grows when you take that approach. That danger is amplified when you apply it to DoD that loves to boil the ocean and have top-down, solve everything solutions to things. So we sort of backed off from that, and it was also inspired by some of the technology successes I think we'll talk about later, where we said, the real power, especially in the short term, is contingency handling. So it really gets to the resiliency piece of it, and maybe even an efficiency piece of it, where I want to start with 99% of what I've got now, but people always talk about the fog and friction of war. Things are going to happen that we cannot predict. Contingencies happen. So that's really where we've been focused over the last several years, is how can we be truly responsive, truly adaptive, but at a managed scale? Because we start by handling contingencies to provide resiliency, and then that puts us on a path that ultimately might circle back to what we call wave 3, which is, buy everything as little mosaic tiles.
You've really distilled this essence of adaptability and resilience. And the idea is focus on those principles, start with what we have, and then be able to scale that eventually to what is a different or evolving force. Yeah.
That's right.
Yeah, so, this theme of network everything together, as you point out, is also not a new theme. Even by department timescales, it's not a new theme. But the world is changing. Dave, there are some high-level DoD strategy documents out there right now that talk about where the department's going and how it can gain advantage. And when those strategy documents focus on the how we'll get there, and call out AI. They call it cloud, which implies connectivity. These are things, cloud and AI, that are out there in the commercial sector, right? I mean, I get ads on my Google search for enterprise SaaS solutions for data-driven decision making. How hard could this be? Why can't you just go out there, click on that ad, and buy some of that?
Yeah, so you should see my LinkedIn account. Yeah, the opportunity to embrace commerciality is absolutely real. These capabilities to run your credit card and buy your cloud instance exist today. What I think is important is to understand where we are in the department, kind of on that arc of being able to embrace some of these software capabilities. We've got to start by getting data informed. To get data informed, that means we need to get good data management and governance practices in place. Oftentimes, whether it's in the department or whether it's in industry, you enter the valley of want, and unfortunately, the AI winter, when you don't focus on ensuring that you can construct testable and repeatable data workflows before you start an AI project. So we're trying to guard against that at every step of the way in the department, to begin by getting our data properly organized against the priority topics, and then move into a place that we can begin to bring automated solutions on top of it. An example, and to Tim's point of having to do this not from higher echelon, but rather start where it matters in the field, really is, I'd highlight Project Maven, and the success that they've had with their smart system through 4 years of hard work in the creation of training quality data sets, labeled data sets. We're now able to count people, vehicles, and a prioritized matter of objects, leveraging computer vision persistently in real time. The work that went into getting the data right so that we could actually develop those models with industry's top providers is substantial, but underappreciated, in my opinion, for the amount of investment and time it takes to actually get to that end. So I think my long response to your pretty pointed question there is we've got to get the data right. Cloud helps us do that. And eventually we will bring artificial intelligence into the fold, but we've got to start with a very tactical solution that we're trying to solve. When we do that, when we organize the data, we can find the proficiency gain through the application of artificial intelligence. And what's amazing is the efficiency that comes along with that, just because we've finally organized ourselves for the first time.
So some of the themes that I heard in that, just to make sure I'm tracking, are one, DoD's legacy systems, technology, et cetera, make for some real challenges in collecting data from those. So what is both our advantage is also a challenge when it comes to becoming more data centric. And the second thing that I hear is DoD has some really unique data and probably some unique needs for using that data, and collectively that just doesn't add up to some simple click a button, make it happen. It sounds like a journey.
Yeah, absolutely, Dan. We have a lot of legacy systems that do not comport to the open data standard architecture that Deputy Secretary of Defense Hicks signed out in her Creating Data Advantage memo. We will have to deal with those one at a time. We work regularly with Lieutenant General Krall and his team on the JADC2 effort, and many members of R&E and DARPA's team are helping us there. try and figure out the point-to-point, system-to-system solutions, so we can create some of those knowledge models to drive, those legacy systems into a degree of compliance. But what we've tried to do with the data decrees and the declaration that we are moving to an open data standard architecture, an industry standard place, is acknowledge that we're snapping the chalk line, what we call no new bad. But we still have to go back and clean up, those vulnerable systems, and eventually sunset some of those, which will be a hard pill to swallow, because we have invested so much into them. But if they can't fit into that mosaic, as you've described, if they can't be a part of that adaptable force structure going forward because they're fully interoperable in time and space in a joint fight, then we really are going to have to make some of those tough decisions about what we bring to the next fight and what we invest in.
Yeah.
So Dan, I can't help but to jump on that.
Sure.
And I know you wanted to also get into the theme of interoperability, so maybe we'll just sort of riff in that direction. I'm going to agree wholeheartedly with Dave said, but also put a slight deviation from it. So we are really, really big in our model. So first of all, as you know, we have a huge focus on interoperability with the technology we've been developing. And I like to say that interoperability goes up and down the stack. So a lot of the work, especially particularly in Dave's office, because that's their mission, as well as at the Jake and other places, has focused very much at the data level. Think of it as the message, the data, the application level. Interoperability there is different than interoperability of networks. And oh, by the way, it even is different than interoperability at the physical layer of data links. You can shoot two antennas at each other, and if they aren't speaking the same RF, you're not going to get a link. So the way we've been approaching interoperability is to break that stack apart, and have been looking at how do we create options to add in interoperability later, so we don't have to wait for big bang moments where or spending tons of money. So we don't have to wait for all the old stuff to go away and new stuff to appear. We don't have to go spend tons of money changing old things. I hate to call it this because it's a gross oversimplification, but it sort of is a glue kind of attitude. How can I create some things, just enough things, even at the physical layer, that can bridge? To the audience, a little foreshadowing. We have a new program about to hit the street called Space Bacon that's looking at creating bridges for satellite crosslinks to connect all these different P-LEO constellations that don't talk to each other. And by the way, that's a good example of where even if we get rid of legacy, interoperability issues are not going to go away. All of these P-LEO constellations have been built to very specific standards, but guess what? Trying to get SDA, Starlink, DARPA Blackjack, Amazon, whoever else is getting that business, to all pause what they're doing and wait until they all agree on one crosslink, that's not going to happen. So this idea of adding interoperability after the fact, I think, is key. It's the federated approach. Now, the thing that I will agree wholeheartedly with what Dave said, when we have worked interoperability at the data level, what we have found is the biggest problem is legacy programs and their vendors don't know their own systems. We might have to have them spend 3 to 6 months effectively reverse engineering their systems and documenting what their interfaces are, what their message types are, down to the semantics of those data, to be able to use it in one of these ad hoc federated interoperability kind of things. So once we get to that point, we can add interoperability after the fact without waiting for the big bang, but there has to be some degree of discipline. And the good news is, I think that's something that we can define standards, not in terms of some monstrous data format, but in terms of best practices, in terms of interface and message and data design protocols that make it discoverable, that make it usable, definable, that have a lot lighter lift and are a lot less controversial than saying thou shalt comply with this 1,000-page data standard document. So that's kind of where our mindset is on interoperability and the question you asked Dave about data.
And And Dave, I want to take that over to you. You know, Tim brought up this contrast. Hey, we've had data standards for a long time, like K-series messages, you know, VMF. We've had standards for data for a long time, and yet we don't have interoperability. So, you know, my question to you is, first of all, you know, how important is interoperability to where the department's trying to go, and what do we do about it?
Yeah. So again, completely agree with Tim. I think when we think standards, we use a little s. That's the best way we can describe it. I've had several conversations with industry's best. I don't think legally I'm allowed to, you know, say which vendors those are, about, you know, why creating a standard with a big S is absolutely the wrong way to go. The department will always be chasing the new thing that industry, academia, and research and engineers are providing us. You know, what we really did move to was in the data decrees, setting conditions that will embrace where industry's at, embracing the ability to make your data visible and accessible and understandable, versus common with a big C. If we really move culturally to that place, then I think we'll be in an environment where the flexibility of options to link data together in time and space based on the contingency that we have at the moment will be real. Again, you know, back to what Tim said, there are still the instances that we have the things that don't comport to that standard that we're going to have to go point to point, that we're going to need, you know, expert engineers with the capability to develop those models in real time to go point to point. But hopefully we increasingly reduce the point to points and move into that place where we do have the Mosaic opportunity, because we're using data management and analytic platforms as the glue, that you can find the data you need, that you can access it, that it's understandable, that it's linkable, right? That it can be trusted, thereby interoperable and secure. And I just listed the 7 goals of the data strategy in order. Over.
Yeah, you know, one paradigm that I've become fascinated with is so often the DoD is focused on, well, it's focused on big weapon systems. So it follows a paradigm that I would call compile then compose. Where compile means I built the weapon system, I created the source code, I compiled that code, which means I froze it, right? Now it's frozen in binary. Compile, then compose, which means now I try to put it together as part of a force package, right? Now I try to use it. And that, you know, gets you into the notion of some sort of rigid interface. You need to know that up front. But if you switch that paradigm to compose, which is, what is it that I need? What is it that I need to conduct this mission? What is it that I need to achieve superiority? And then compile. And there might be a number of ways to do that, but first compose, then compile, right? Suddenly, all of those, that whole set of issues and the whole way we think about standards could change. But boy, that sounds like we need a tool chain, and you know, I fear that's a long journey for the department.
Well, except Dan, that's what we've been trying to build.
Exactly.
And I want to riff on one other thing, and this is really important. And again, agree completely, but put a slight twist on it. You know, when Dave talked about those cases where we need to go build those sort of custom engineered links, to the point about a tool chain, what we're really trying to drive toward, and this gets to another really important point back to your earlier question about evolution of the thinking here. I actually believe we can get to the point within the next few years where we can have enough of that tool chain, especially at the data layer, as we move further and further to the physical layer, it gets harder and harder, where we can start composing effectively those custom links in the field at operationally relevant times. And I don't think it requires an engineer. One of the other themes that's been going on, and with things like Jake and some of the AI work, some of the things like Maven that Dave alluded to, the various DevSecOps software factories around the department, those have moved the timeline for development from a program office in years to people that can start writing code at mission relevant timelines, more focused on specific need, more specialized. I think we're at another tipping point, and the problem is the distinction here is very subtle, and the department hates subtlety. But there's a different, even those people doing AI, even those people doing DevSecOps, they're still developing something. They're still writing code. So you need someone with a certain amount of software acumen or programming acumen or engineering acumen, albeit more tactical and maybe less specialized. We're advocating for something even further toward the operational edge than that, something that frankly is technicians. And so we're trying to equip these people that are technician level skill sets, not to actually develop anything, but to use tools, to your term, that are essentially composition tools. So those customized links or those customized data interoperability things that Dave referred to, which again, I think we're always going to need to some degree to handle those contingencies. We've moved this notion of Mosaic and this very big systems level think from being an acquisition RDT&E problem that has to happen sort of in that Pentagon PEO world down to something that's at the tactical edge. I've been working on a term, and it's actually appears in some of your report, something like a mission integration unit, or I like to colloquially call them a geek squad. So I think that's one of the paths that we're on, and that's really what we hope our tools inspire and then ultimately equip.
Yeah.
If I could jump on that one, and I know Dan now Tim and I are having the conversation we're probably going to have in my office in about 30 minutes. But I could not agree more. And people will forget everything about this engagement, a week after they hear it. But hopefully a story, will help bake that into their memory. So 2 weeks ago, I was fortunate enough to be down at Fort Bragg with my good friend, Major General Chris Donahue, CD. As he was packing his bag, quite literally, in his office, getting ready to lead his formation into Kabul for the NEO. As we were talking about, I tried, I was texting him, hey, I'm gonna wave off, brother, you're busy. No, now you need to come. And graciously, he hosted myself, the Army CDO, Dr. Dave Markowitz, and the director of Advanta, Greg Little, to just get a sense for what do you need. And while we were in there and we were hearing about how he was using Project Maven's smart system to build their operational plan and to build their, mission command application and how they were going to use it at the airfield. And, the good news is he helped us design it at NSOC Alpha when he was the commander there. So he understood what he wanted. What he really said he needed, he said, Dave, I'm only going to ask for one thing. He said, I need my tactical data team. I need the geek squad, the data experts who, when I get on the ground, can take these tools that exist today that comport to that open data standard architecture and help me engineer the data into them to generate the decision advantage I need in the battle space time now. It really is about that human capital. It's the only thing the outgoing commander heading into, our nation's nearest fight right now, asked for, was the human capital with the technical acumen to help him unleash the data to generate proficiency and efficiency of operations. That ties into the DepSecDef's ADA initiative, where the first step of this is to deploy operational data teams with, 2 modern data management platforms to the combatant commands and the joint staff, so that we can begin to unleash that data. It's the geek squad. It's the bridge to the future. Could not agree with Tim more. Over.
Yeah, I love that story because it reveals that, here's this timeless thing about conflict. It's about the people, and it's all about the human capital. And at the same time, it also reveals the changing character of conflict, right? Because there's this need for, at the edge, this ability to capture and leverage data. Look, there are things. I mean, we could talk for hours. I think we could collectively riff on this topic for hours. Let me try to zoom out just a little bit and get in a couple lightning round questions. We're gonna fire a couple questions off to both of you that zoom out a little bit. And first, on this notion of changing character of conflict and what that means for the department, Bryan's charts suggested that, as you move to new eras of warfighting, as the character of conflicts change, the metrics you need to think about also change. And, collectively, we know the kind of metrics that the department cares about and thinks about today, right? When it comes to overall performance, are our programs on schedule? Do we have good obligation rates, good execution rates? When it's weapon systems, right? What are the kinds of requirements we have? Performance characters, speed, range, signature, and operations. We talk about readiness. We talk about availability. When you think about a better future, do you think about different kinds of metrics? And if so, what are some of those kinds of metrics? And Dave, I'll start with you.
Yeah, I'm careful when we talk about metrics because I think metrics are good, outcomes are better. And when we overemphasize metrics and counts, we don't necessarily pay attention to the object and end we're trying to generate the effect for. Now I'm a data guy, so I love numbers, and I can go into analytics from here to tomorrow. They are drivers of good data management practices, as we can hold them up and hold you to KPIs and measurables. But really, I think it's about how we're focused on the end and the effect that we're trying to generate. So that's kind of where I am. I've seen the department over the last 16 months that I've at least been in this position, move from the boardroom to the battle space. And when we bring those two metrics groups and outcome driven pieces together, it's been pretty fascinating to see the success that we really have been able to generate. What I'd really like to focus a little bit of time on and get Tim's thought on is how we actually generate the outcomes we're trying to achieve by inventing the future in the kind of PPBE process that we have today that I struggle with, and I imagine he has a lot more experience with. I had to even learn what PPBE stood for when I first got here. But how we take some of the awesome stuff that DARPA's doing and move it into operations because we can buy it, invest in it, and integrate it at a faster rate on a POM cycle that only allows incremental improvement to programs of record. Over.
So I'm gonna address Dave's question he posed to me and Dan's simultaneously. So and I'm gonna start with a metric that's going to sound really, really weird coming from a DARPA person. We need some kind of metric on headcount. Back to the human capital discussion. So I actually think a lot of what we're doing can bypass that whole PPBE business, because if you're talking software, again, now if we're building a new hypersonic missile at DARPA, that absolutely needs to go through some kind of process through a program office. If I've got a new software tool that enables interoperability or enables a different type of adaptive communications or something of that nature, when it starts, it's pretty wild, heady, low TRL stuff at DARPA. But for software kinds of things, it can mature to being directly usable in a couple of years. Why does it now need to go back into a PPBE process? And we've seen this in one of our programs. I think a lot of the folks listening to this have probably heard me talk in the past about something we have called Stitches, which is a tool to do some of this ad hoc creation of interoperability at the data and the message level. Stitches is transitioned. There's no more development on the software tool. The software tool gets used by people, by human capital, by the geeks to go do integration activities. So Stitches, we actually didn't succeed in this. We tried really hard, and I think we'll still get there. We wanted to make it go into an O&M program. and bypass RDT&E and the whole PPBE business. You still have to justify budgets. You still have to justify resources for an O&M line. Sometimes it's trickier. And we don't have a good basis of estimate yet. To Dave's example about the special forces deploying to Kabul, that's one example. So there's a seat of the pants example of about how many geeks do I need to provide data support for that one deployment. We need to start today, whether it's training operations, whether it's something like ADA, whether it's something like other modeling and sim events, to understand where would I need that human capital to support this just-in-time composition, and then use that to start generating a basis of estimate to justify people. Now, here's the weird DARPA thing. Long-term, wave 3, and Dan alluded to this earlier, and it was even in some of Bryan's talk. We have looked at the notion of can we acquire new systems? This is now populating the tiles in the Mosaic artist's palette. Bryan's chart with the ships all being replaced with smaller ones. We ultimately would like to get to the point where metrics are not KPPs for the performance of those things. There might be a temporal metric. There might be some kind, how fast can I deliver this? I'm going to do 2-year program centers. Doesn't matter what you've got, go. By the way, the Navy has done this in I think a pretty exciting program that's been around for a long time, ARCI, that delivers sonar algorithms that way. But that's a metric. But the magic, and I wish I had a very specific answer. And this is actually, I think, an interesting AI problem, and something that we have been exploring a little bit as a more fundamental research thing, is could we create, to use a very technical term, the AI-based gonculator that can look at things not based upon I've defined a performance requirement, but more bottoms up. What can the thing do? Someone comes up with a great idea for a new widget. What can it do? Assess what it can do really well, and now throw it into the AI gonculator to provide a mission effectiveness metric against it. And that becomes a question of, okay, now if it moves the needle, that's something I ought to invest in.
Yeah, first of all, I hope you both appreciate, Dave brought up PPBE. It's taking a great deal of self-restraint not to go down a PPP rabbit hole with both of you, because I know we have strong opinions on this, and there's so much to explore, re-examining, the assumptions of a system built in the industrial era for a different time. But Tim, this theme that you brought up about the role of technology, and presumably also the role of data in rethinking some of the institutional processes and rethinking how we think about fourth generation, I think is really ripe. But one of the things that I struggle with there is it's not obvious how the department does that, right? We don't have a process to rework the process. We have a process and we work that. And I know you both have opinions about that. I am conscious of time. I think we have time for one final question, and I'm going to try to, I'm gonna riff on Dave's comment. Let's look at some outcomes here, and there's an outcome that's at the top of mind for a lot of people in the department right now, which is can the United States maintain a competitive advantage against China, typically viewed as a pacing threat, and if so, how do we do that? How do we maintain our advantage? And the question I want to ask to each of you is, look, China's investing in communications and AI. They're collecting data too. We're talking a lot of the same ingredients. So in as much as in this conversation, or the department as a whole is focusing on these ingredients, why is it that it's not just a Me Too game? China has data and AI and comms, and we have data and AI and comms. Where is the US's hope for a strategic advantage? Where's the asymmetry? And Tim, I'll start with you.
All right, so I am going to be a little bit of a pessimist on this, and maybe a little bit controversial. I am actually concerned about a government-driven effort being able to win in that competition. And the basis of my concern, and please, I don't want to take this the wrong way on anyone who's really out there fighting the good fight, and I've got full hope that Dave is going to fix this from within the government, and others like-minded. But one of the worries is to really take advantage of this. It comes back to either speed and or bulk. Guess what? A top-down dictatorial country with over 1 billion people has the ability for speed and bulk, even if it isn't, the most highest in efficiency or the highest in innovation. And as a department, as a government, we typically don't do well at speed or bulk. We like to optimize. We like things to be viewed as efficient. We like them to be very carefully planned. And those kind of run counter to speed and mass. I do have some hope. And the thing that is really the U.S. pride of the world is the private enterprise within the U.S. Private enterprise within the U.S. dominates. I think the answer to stay competitiveness is to look for public-private partnership. We don't have time to go fully down this rabbit hole, so maybe another discussion. But one of the things I've been exploring right now is this notion of X as a service. Could we have a situation where industries, maybe they've got a basis in the commercial world, maybe not, but companies that are out there privately funded, that can innovate on their own, moving at commercial speed, all the way, not just IRAD, but to develop a usable capability, a fieldable capability, and then let the government buy that as a service. I think if we can figure out a way to tap the full innovation and mass and speed of the U.S. Broader private enterprise, we will win.
Yeah, and Tim, I think that's an interesting point. You sort of zoom out to the industrial base and how you interact with the industrial base, and you seek innovation there, a historic source of U.S. strength. Yeah, one thing I might add in is I do think the U.S. has a potential for decision-making advantage that comes from pushing decision-making authority to humans at the edge, which is related to our comfort and trust of people. It's a means to generate surprise, and that's a possible angle to leverage human advantage there. But I want to turn it over to Dave. All right, where can the U.S. hope for strategic or asymmetric advantage in this coming era?
Yeah, so kind of taking a branch off Tim's great start. Yesterday I had the opportunity to do a fireside chat with John Chambers at the CDO Council, the DoD CDO Council. He gave us an hour of his time to just talk to the data leaders across the department. There are over 600 people on our net. And tell us what his thoughts were on the strategic competition, where we're going, where we need to go. He absolutely focused on the need to embrace commerciality. He also focused on, hey, find the organizations inside the Department of Defense that want to change now. Find the radicals, and place your bets like a venture capitalist there. Put your time and energy on those people who are ready to change, and make sure that you are clearing the path for them, because that's where you will transform the department. And I think we're doing that. That said, I'll flash back to a conversation from a couple years ago with President Reif at MIT. When he was talking about the strategic competition, he said there's no way we can slow a near-peer competitor down, to Tim's point on speed and bulk. He said we damn sure can speed ourselves up, right? And we speed ourselves up not by believing that we as a government can do it ourselves, but it is in that public-private partnership. And it's also embracing the advantage America does have, which is our diversity. It's our ability to imagine different things because of that diversity, and to compose and then compile, using your terminology from earlier, new and inventive ways to not just use the technology we have today, but design the idea of the technology we want. And if we can speed that up, and again, find a way to work through that PPBE process, or not, to Tim's point again, we've got the geek squads out there, they can just invent it themselves. Then I think we do stay ahead. As far as bulk, what I would say, and maybe this is just the Marine in me, I'll go back to General Tony Thomas, a good friend of mine, the former SOCOM commander. He said he'd go toe to toe with anybody who's never been punched in the face. We have combat reps. We also have combat data. We also have an exquisite ISR capability that has been developed, not just in the last 20 years we've been in Afghanistan, but the last 50 years in partnership with DARPA and NRO and everybody else that's been embracing commerciality. We're only improving that today, and we know how to organize our data to prepare those training quality data sets. So in time of need, we can find the right commercial partner to come in and help us build that awesome model. And on the human capital front, we're increasingly finding those junior officers, those junior enlisted members who go, hey, if we can do that, can we do this? And they're getting better and better at the integration. So I think the future's bright, and I think we're trending properly. But again, to President Reif's wise words, we can go faster and we need to.
Dave, I think that is a great and compelling note to close on. So with that, just want to thank you both for participating, and back over to you, Bryan.
Thank you, Dan. Fantastic conversation. Lots of great threads that we need to pull on in future research and events as we continue to explore the implications of this new trend in warfare. I want to thank our guests, Dr. Tim Grayson, Mr. David Spirk, for being here with us today. And Dan, thank you for leading the discussion. And I also want to thank Kirsten Moeller for producing this. And hopefully you'll be able to get a chance to look at our reports that are related to this. They're on the Hudson website. And from the Hudson Institute, have a great day. Thank you.